Whoops. Hey guys, welcome back to Speedrunning Math. My name is Ariston, and I'm the host of this channel. And in this series, I do statistics and, stuff, and work on my math skills. So let's go straight into my message of the day to you, the audience. And by the way, I have like 60 subscribers. Every time I upload a video, I gain like 2 subscribers, which is like astonishing because no one leaves the freaking comment in my video. So if you're watching this right now, leave a comment, say something funny, say something about math, about how lame it is, or how epic it is. I don't really care. Okay, message of the day. This one is a crazy one with Shanks in the background. So it's a quote from The Art of War. The original piece was in Chinese, but this is essentially what it means in English, according to Google Translate. And it goes, victorious warriors win first and then go to war, while defeated warriors go to war first and then seek to win. Essentially, you have to prepare. It's like Usain Bolt, sprinter, one of the best sprinters in the world for a long time. Um, he talks about how training is hard, winning is easy, because in a sprint, to cross the finish line is just a step compared to the journey took um that took place before it. So yeah, prepare well and just prepare well. Don't really have to expound. Just prepare, prepare, prepare. Don't show up on game night not having prepared, expecting to win. Okay. So let me just timestamp this. Math begins. 2 minutes exactly. Nice. Okay. And it says here my 12-week streak was actually about to end, but we're gonna do some math now and it's gonna continue, which is pretty good. Can't believe it's almost been a week since I last did math. That's really bad. Okay, let's watch constructing a scatter plot. Okay, let's put out more chapters. Scatter plot. Oh yeah. I have to say that this is probably my favorite series among all of the
Aubrey
ones I
wanted to
do.
see if there's a connection between the time a given exam takes place. She collected data about exams from the previous year.
Okay.
Plot the data in a scatter plot. Let's see. They give us a couple of rows here. This is the
Yeah, so scatter plots are pretty straightforward. What are they? Okay, you have a X and Y grid. Imagine like a Cartesian plane, and then it goes from 0 to 100 or whatever, and then same with I'm gonna show you what it means in a
class
bit.
that
Okay.
we have to be a little careful.
But how this works is you have two axes. In this case, it'd be average score and period, and then you just plot them like an X and Y grid for each point. So each of these columns will be a different point.
The horizontal over there. 2, average score of
Yep,
80.
and it's gonna end
1
up
average
looking like
score.
that.
Yes. Any
Okay, scatter plots. Plot the data in the scatter plot. Okay, so we have 1, 2, 3, 4, 5, 6, and we see it's organized from left to right. Weight is this axis over here, as indicated by the label over there. So what we are gonna do is just go one. Whoops. They've updated the layout. Oh, never mind. Whoops. It goes 1, 2, 3, 4, 5, 6 for age, and then weight is 1 to 7. So just 4.25. I'm gonna put that here. Oh, whoops. 4.25 for 1, 5 for 2, 3, 5.75 for 3, which is about here. 6.25 for 4, 6.75 4, 5, and then 7, 7 for here. Looks about right. 1.75, okay, and then same thing. You have to pay attention to which row or which column, yeah, which rows correspond to which axis. So the score is the y-axis, and the study time is the x-axis, or horizontal axis. So, okay, and these are not ordered over here, so we actually have to keep in mind the order. So I'll just do order over here, order. So 1, 2, 3, 4, 5, and then 6. So it's just saying left to right, you know. So for 0.5 study hours, we have 7. Oh, darn. Okay. I won't be able to show it while I do it, so we'll just do it like this. 7, yep. Then 1.5 at 15. And then 1.75. So between 1.5 and 2 at 17. Yep, just there. And then 2, 16. Okay. And then 3, then 3.25, 19 and 20. Okay. 3 is 19. And 3.25 over here in the middle, almost got that wrong, is 20. Nice. Okay. Check. Next. Okay, let's see here. Gold is the x-axis, and then silver is the y-axis. Yep. Okay. Let's go 2, 3, 4, 4, 8, 9. So it's reverse order. Okay. 2 is 4. 3 is 1. 4 is 1. 4 is also 4. And then 8 is 4. And 9 is 13. So all the way up here. 100, 200, 150. Okay. So coffee is the horizontal axis or the x-axis. So go by coffee, 100, then 125, 150, 200, 225. Okay. 100 for 18. 125 for 20. So in the middle. 15 15 for 150. 15 for 150. No, 150 for 15. So over here, yep. 200 for 14. And then 100 for 18. Okay. Wait, 100 for 18. I just realized I don't actually have to do it in order, left to right, right to left. If you do them one by one anyways, you'll end up doing all of them. So let's see what we've done. Okay, so we've done 100, 125, 150, 200. Huh? Oh, now 225. 225 is 12. Nice. Okay. Flower height, petal length. Oh no. Okay, we're gonna skip ahead. Estimating. Oh, okay. So we're estimating the line of best fit. And line of best fit, it's not actually a regression model, I don't think, but it's like just an exercise, visual exercise to determine whether or not there is some sort of correlation. Not correlation. No, yes, correlation between two variables. It's similar to linear regression. Yes, okay, I'll end there. It's quite important. Line of best fit. 1037. Whoops. Yeah.
Find the line of best fit or mark. Find the line of best fit or mark kind of approximates something. There's no.
Yeah, nah, this is fine. This is super easy stuff. You learned this in like second grade. Which line fits the data graph below B? E, none of the lines. E, B. And none of the lines. Next. Estimating with linear regression. Okay, so with linear regression, use y equals mx plus b, but there is a different different formulas for linear regression. So a linear regression, I guess, are these also the same? I'm not sure what the names are for, like, I'm not very good at math. uh, but this is like simple linear regression. So you have your y at I, and then you have your beta 0, beta 1 times x at I plus the epsilon I, which is just error term. So essentially, what this is saying is that you are trying to predict this y at I. This is known as the dependent variable, and you arrive at it by getting beta 0, which is the y-intercept in your linear regression model, and then you have your predictor and its coefficient, the independent variable, and the like variable coefficient slope, population slope coefficient apparently, and that is your linear component. And then the random error component basically is like you're trying to explain variation that isn't captured by the model in the random error term. Okay.
Liz's math test included a survey question asking how many hours students spent studying for the test. The scatter plot below shows the relationship between how many hours students spent studying.
Which of these linear equations best describe the given model? Okay. So how do we figure this out? Okay, so in y equals mx plus b, this is just a linear equation. And if you think about y equals mx plus b, it actually is pretty similar. It basically is the linear regression formula. It's just that, look, so you have your y, and then if you go back here, you have your y, and then you have your mx component, which is this, and mx in this is just like this and this. That's mx, right? And then your beta 0 plus, that is your slope. I mean, that is your intercept, which is effectively this plus 20 over here. That's the intercept. And the reason why a linear equation, the only difference really is that the linear equation doesn't have a random error component. Because if you have a linear equation, you're not estimating anything, right? You're just saying that here's a line. So, okay, let's go back. Side tangent. Y equals 20x plus 20. Oh, okay. How do we solve this? So, y equals mx plus b. We don't need to know the y. I mean, we could. What we could do to solve this is one of the more like straightforward ways is substitute y with any of the values here at this point, at any point along this line, substitute y and x, and then you'll see which is which. Um, Otherwise, oh, actually, I didn't finish reading the question. What you'd want to do actually is substituting x into 3.8 into x into any of these equations, and then see if it gives you an accurate y, right? So it's obviously not the third option because it's negative 20x. So if you did minus 20 times 3.8, you would get a pretty large negative value. And even if you added 20 to it, it would still produce a negative value. So scrap that. And then between 10x and 20x, what would be the answer? Well, you can think about it like this as well. For let's say a value of 0.5, like study time, you substitute it and you see which gives you the appropriate y. So 0.5 just means half. So the value for 0.5, the value for score at 0.5 study time hours is 30. We can see it over here. So what of these equations, if we substituted 0.5 in for x, would give us 30? So let's go through option 1. 0.5 times 10 is 5 plus 20, that's 25, so obviously that's wrong. Option 2, 20 times 0.5 is 10 plus 20, that's 30, so that's right. So option 2 is pretty quick.
Have a y-intercept of 3 over 1. So this is
I
going to be our
waffle a
slope.
lot, but like if you made me solve for the answer, I could do it in like 10 seconds probably. Okay, maybe not, maybe like 20. I'm just trying to explain in depth to try and get the message across, but sometimes I can lose you. So sorry about that.
Have to be careful
Not sorry.
extrapolating with models and take a grain of salt.
Ah, fuck. I was supposed to answer this, but yeah. Line of best fit, smoking in 1945. Okay.
The graph below shows the percentage of American adults who smoke over time. Assuming the trend shown in the data has been consistent since 1945, use the graph to 2%, 19 and think negative 20 years since 1960. It looks like
when you draw the line of best fit, I don't know. You just try and fit as many of the points as possible. I guess you try to go center through it. Estimating slope of line of best fit. Which of the following is the best estimate of the average change in the number of accidents associated with a 1-year increase in age? Hmm. Okay. Which of the following is the best estimate of the average change in the number of incidents? Okay, let's think about it. So it goes from 23 to 11 over 8 years. How big of a change is that? So 12, 8, 12 divided by 8. It's 1.5, so negative 1.5. I'm gonna go with that. Which of the following is the best estimate of the average change in mood rating associated with a 1-hour increase in hours playing sports? Okay, same thing. We'll take x0 and x equals 3. We'll see the difference and then we'll go with that. So it was roughly 5 here, 5 and 10. So difference of 5 in 3 hours. So Oh wait, okay. Which of the following is the best estimate of the average change in mood rating associated with a 1 hour increase in playing sports? Okay. So since we're dealing with 1 hour, we'll try and make this fit, I guess. I'm gonna go with this and this because I feel like, I don't know, I just have an intuition that it's pretty good to go with that. Okay. So it goes from 7 to, nah, not that. Okay. Uh, this and this. Okay. Between 0.5 and 1.5, what is the change? Okay, so it's kind of like, oh wait, what? Wait, what was I doing a while ago? So, eh and eh. With a 1 hour increase in playing sports. Fuck, I'm just gonna go with 1.5. I feel like the others are just too high. Which of the following is the best estimate? Okay, so it has to be negative for sure. And it's quite drastic, so I'm gonna go with negative 15. Ah, fuck. Restart. With a 1 hour increase. Okay. Let's actually try and get wrong so we can see the... Okay. Since the data shows a mostly linear trend, we can draw a line to estimate the rate of change. Here's one that works. Approximation for the slope is this. So it's literally saying draw a line and get the freaking difference. Okay. So let's say it's like this. Mm, is it y2 minus y1 over x2 minus x1? So let's say this and this. Uh, this is roughly, okay, so 25 minus 25. And let's take this 80, 80 at 70, okay. 80 like that. Dude, okay. This is x. 25, it was 20. Hmm. And at 80, it was 70. 50 over like that. And then, fuck, it's 55. This is pretty close to 1, to be honest, so let's go with that. Okay, same thing. So get x2 and x2 and y2 first, okay. 4.5. Now we'll go with this and this. So x2 is 4 and okay, so x2 and y2 are 4 like that. Minus um 1.5 is the x and 5.7 is the the fucking top bit. Just say 6. So negative 2 over negative 2.5. So slightly less than 1, but closer to 1 still, so it's negative. Also, this is not negative. Oh. Which of the following is the best estimate of the average change in a school person's income? What am I reading? Which of the following is the best estimate of the average change in a person's income that is associated with going to school for an additional year? Okay, so let's just draw a line of best fit, kind of like that. Let's take two random points. Uh, Maybe we could draw it slightly better. Let's plot this actually. Another way I just came up with is, so this is saying for each year it would go up by 3k, right? So from here, if we go 20 years, it would look like if at year 0 it's 0, and at year 20 it's 20 times 3,000, uh, that would be 60k, so it'd be over here. So it would kind of look like that. Kind of look like that. Oh my god, I'm really bad at drawing. Let's use a different color. It would look like, oh my god. It would look like that, which is too slow. So we know that it has to be 7k, right? Same thing here. Ah, this is saying, which of the following is the best estimate of the average change in shoulder height associated with a 1 cm increase in foot length? So we can actually just, because our scale is in tens instead of ones, we'll just add, we'll just say this is like 10, 20, 60, 120. And then let's just go from here and draw like here, 60, right? This is the 60 point. So 60 times, and this is roughly 320, let's say. 60 times what would be the closest value to 320 or 280 or whatever. Actually, let's stick to 320. 60 times. Actually, hold on. Hmm. I just thought about something now. Okay, let's go over here. 50 is roughly at 280. So 280 divided by what multiplied to what? 50 times, let's just call it z. Okay. 280 divided by 50 equals z. What's this roughly equivalent to? 5.6. So the closest answer is 6 cm. Cool. Okay. That was oddly difficult for how basic it was. Just goes to show that you're never too good to go back to the basics. What is this? Estimating equations of lines of best fit, using them to make predictions. Which of these linear equations best describes the given model? Okay, so it's one of the top two because the intercept is 800, and we can see that the thingy starts at 800. So 2.5, 40x, I'm gonna say 40x because 2.5 is like really, really slow. It's a very slow of a rise. Based on this equation, use the equation to estimate the average trend in 2020. Years after thingy. So we're gonna go 40 times 20 because this is years after 2000. So let's just that plus 800, 1600. Which of these linear equations best describes the given model? Same thing. Okay. So at x equals 10, we have um like 125, I'm gonna say. So let's use some algebra to solve for it. So y equals mx plus b. We know our y is what do you call this? 125. So over here. Is that right? I'm gonna say that's right. So 125 equals m at 10 plus, and our our intercept is 5, so immediately removes these out of the equation. Ah. And then we can move things around. So 130 equals divided by 10. Oh fuck, what am I doing? Oh wait, nah, yeah, that is right. So move this over. Nah, it becomes 120. 100 if we minus 5 to both sides. 120 over 10 equals m. And so we get that 12 equals m. So this has to be our answer. 1,000 kilometers. Oh yeah, and then all we do is plug the stuff in. 12 times 7 plus 5, 89. Which of these linear equations best describes the given model? Yeah, so intercept is 5, and it has an upward trend, so it has to be this. And then based on the equation, 1.5 times 2.5 plus 5, 8.75 to the nearest hundredth. It's all good, we don't need the nearest hundredth. Okay. So we see that our line starts in the 0 value, so um, no, our intercept is 0. Y-intercept is 0. So we're left with 2x or x. As we can see here, at x equals 10, y is equals 10, and this goes for all of the values of x. So it has to be x. Basically what it's saying is the x and y are the same, 1 to 1. 88. Is that reasonable? Yeah. His first exam score. Yep. Up next article. Phone data. It's all good. We'll push through this. Yep. Okay. Quiz 1. Quiz 1. 34 and 35. 5 questions, 5 to 10 minutes. Plot the data in a scatter plot. Okay. Let's do it left to right. Okay, so right foot is our x-axis, horizontal axis. So we're gonna go 29 and at 6. So 29 is over here and we go to 6. And then we go to 12. 12 is over here and we go all the way to 26. 26. And then we go to 24 and 24 is up to 1, which is roughly over here. Then we go to 7. No, we go to 18. And then we go to 7. So it's over there. And then we go to 1, which is over here. And then we go up to 16. So over here. Which line fits the data graph below? A looks good. Which of these linear equations best describes the given model? So we can see that the line intercepts the y-axis at roughly -20. So immediately we're only looking at here or here because the y-intercept, the last number that comes after the plus or minus sign is -20. And then we see that we have to choose between 6x and 3.5, 3 over 2x. From here we can just plug in some dummy values and see what's what. So if we look at this point over here, this one that I'm drawing, 60, at something equals 60, 60, let's just say m, because mx plus b, right, minus 20, it should be roughly equal to, let's just say 300, 310 if you want to be like specific. Then from here we just do algebra, shuffle things around a bit. So 330, let's just do 300 so it's easy. 300, what am I doing? Wait, it was 310, right? Okay, let's just stick with that. Minus 20 plus 20 to both sides, 330 equals, and then over 60 equals m. And that's roughly 5.5. And that is closer to 6x than 3.5, 3 over 2x. So we go with that. And then we just plug in the stuff. 6 times 45 minus 20, 250. Which line fits the data graph below? None of them. Plot this data in a scatter plot. Okay. Left to right. Sick days. This row goes okay. So we go 6 for 6, and then 7.5 over here for 7, and then we go to 0.5 over here, and we go to 7 again, and then we go to 3, and then 7 again, and then 4, and then we make that 5, and then we go to 9.5 over here, and we make that 6. Ah, man. Are you fucking joking? This is such a time-consuming, like, task, you know what I mean? Show summary, retry. Uh, wait. What? I didn't get marked down, it seems. Not tested. Wait, what? 80%. I got, yeah, let's, I got none of the lines. Fuck. This is just a confuser, I'm pretty sure. Yeah. Oh, man. 11, predicted. I gotta go here. 14. And then we go to 13. Over here, 15. Then we go to 12 for 12. And then we go to 17 and make it 16. And we go to 15 and make it 14. And we go to 27 and make it 17. Oh my god. I'm fucking tripping, dude. It's just supposed to be over here. 17, 27. I must have fucked up like several times. So dumb. Okay, I have an idea. So I'm gonna do one. So period is going like horizontally. 1, 6, 2, 7, 3, and 4. Then from here we just go to 1 is 60, 6 is 90, 55, 2 is 55. Computer science is 795. Math is 60. Biology is 80. C seems to be a decent fit. And then should be, yep, plus 42 for everything. It's not negative x. Okay. Let's say 15. 15. 15 at like, okay, let's say 6. 17, let's say 18. 18 at 6. 18 minus 42. 18 minus 42. That is 24. Yeah, 24. 24 divided by 6. Oh, yep, it's minus 4x. Negative 4 times 3.5 plus 42. 28. And you can see 3.5. There should be roughly 28. Yep. A kind of fits the data, so that's fine. This is what the fuck this a while ago, so oh, I swore. My bad. Okay. This is pretty neat. So 0, 1, 2, 3, 4, and then we just want to move this to 5.5, 6.5, 7. Why is it 2? 5.5, 6.5, 7, 750, and then 750 again. Next, lesson 3.
Base 1.
Okay, so we're gonna do logarithms now. What are
Let's
logarithms?
learn a little bit about the wonderful world 2. 2 times 2 is 4.
In math, you can express numbers as exponents or logarithms. So, what an exponent is basically how many times a number is multiplied to itself. It's essentially just another way of writing a number times itself, times itself, times itself. The number in the exponent of a number is called the degree or the power. So this would be read as 2 to the power of 4, right? There are 2 with the exponent 4. And this big number is called the base. And the small number is, again, the power or the exponent. And what a logarithm is just explaining the base and the exponent in a different form. So instead of it being base exponent, it becomes um oh man, what does it become? Bloga. B log A. So this is base to the exponent, and then
Times
here,
2.
you'll
Worst
see what I
example.
mean.
Log base blue of 16 is equal to what? Or is equal in this case, since we have the x there, is 2 to get 16, and I'm going to set that to be equal to x. And you say, well, you got to raise it to the 4th power. Once again, x is equal to 4.
So these are equivalent expressions. Um, 2 to the power of x equals 16 is the same as 2 raised to what power gives you 16, and this number is equal to x.
That out of the way, let's try
So you would say 2 raised to the power of 4 is 16, so therefore x equals 16.
more examples of
I mean,
evaluating
x equals
logarithm.
4.
What would raise 3 to 3 log?
Same here.
Well, just
And again, 3 in this scenario is the base. And, oh, there's one more thing that I'm forgetting. Okay. It's the base, the exponent, and the argument. That's what bloga stands for. Okay. Logub. Logba. Something like
as
that.
a reminder, this is to be as 3.
And the argument is basically what an exponent is after it's been like simplified. So to the power of 3, for example, it's 2 times 2 times 2, which is equal to 8. So 2 to the power of 8 equals 2 to the power of 3 is equal to 8, which means that 8 is the argument in that case. In logarithm form, the base and the argument are on the same side, and the power is on the other side.
3 to the very get 2. The x is based. Well, give a shot on your own now that we get, and you'll hopefully get the hang of it. So let's try
Well,
a little bit to 6.
okay, we'll move on to the next. Move on to the next. Log 5, 125. So it's saying what do we multiply to? What power does 5 need to be to get to 125? So I'm gonna say like 3. Log 10,000. Log 10, 10,000. Okay. Log to the base 10, 10,000. That's how I would read it. Might not be right. So 10 times 10 is 100, times 10 is 1,000, then times 10. So I'm gonna say 3, 4. Yeah. 2. Fuck. 5 times 5 times 5 times 5 times 5. 1. Not 2. 2, 3, 4, 5. So 5. Okay.
Use a calculator to find log base e of 67 to the nearest 1,000.
Okay, so let's see.
So just as a reminder, E is one of these crazy numbers that shows up in nature and finance and all these things, and it's approximately equal to 2.71, and it just keeps going on and on and on. So
Okay,
you could view
interesting. So E actually has a value in math, kind of like pi.
log base E as 67. You might say, what does E mean? E is just a number, just like pi is just a number. So this is really the same thing as saying log base 2.71 and the actual number. So you'd have to write all the digits that keep on going
Yeah,
forever
okay.
and never repeat. Of
So it's
67.
not
So
really
what power do I have
special. If you do log 1, log 2, log 4, log 5, doesn't really change
to raise
anything.
e to get to 67? So another way of saying that is that if this is equal to x, you're saying e to the x is equal to 67. We need to figure out what x is. Now, traditionally, you'll never see someone write log base e, even though E is one of the most common bases to take a logarithm of. And so the reason why you wouldn't see log base E written this way is log base E is referred to as the natural logarithm. And I think that's used because E shows up so many times in nature. So log base E of 67, another way of saying that, or seeing that, and the more typical way of seeing that is the natural log. And I think that this is ln, so I think it's maybe from French or
Okay, so log with a base E is also known as a natural log.
something, log natural of 67. So this is the same thing as log base e of 67. This is saying the exact same thing. To what power do I have to raise e2 to get 67? When you see this ln, it literally means log base e. Now, they let us use a calculator, and that's good because I don't know off the top of my head what power I have to raise 2.71, so on and so forth, to what power I have to raise that to get to 67. So we'll get our calculator out. So we get the TI-85 out. And different calculators will have different ways of doing it. If you have a graphing calculator like this, you can literally type in the statement natural log of 67 and then evaluate it. So here, this is the button for ln, means natural log, and then press natural log to give you the answer. But a graphing calculator can literally type it in the way that you would write it out, and then you press enter. So 4.20469, and we want to round to the nearest thousandth. So this is a thousandths place, 4.2, and it is 81. Fourth power,
Okay,
power
fair
2.
enough. Okay, unit test. We're probably not going to get tested on natural logs, but it's fine. Unit test. Fuck, I don't know, like 5. I gotta swear less, guys. Makes me sound less expressive, and I already am pretty, like, monotone and dead, so. Yep, none. Well, actually, okay. So what do we go with here, fellas? This question is asking us linear equation, what linear equation likely fits this. Um, so what we can do is, okay, well, okay, quickly to explain. Um, the intercepts are all right, so they all start at 7.5. It has a negative trend, so negative x or negative 1/2 of x are possible answers. Negative x seems plausible because at x equals 4.5, the answer is equal to 3, or the y is equal to 3. And so if you do 4.5, like 7.5 minus 4.5, that's 3. So go with that. Negative times 5.5. What? 2. Well, we don't actually even need to use the equation because we can just look at the equation because this is the equation of this line. So you go to 5.5. Ah, no, we actually do. Fuck. Uh, 5.5. Let's say like 2. What do we multiply to? What exponent does 2 need to get 4? 2 multiplied by itself. Plot the data in a scatter plot. Okay. Study time is the horizontal, as we can see. So we'll just plot out all of the little points. 0.7, 1, 0, 3.25, 0.25, 2. Okay, now we go. 0.75 is 15. Whoops. Then 1 is 13. 0 is 7. Oops. 7, 7. 3.2, 2 is 16. 3.25 is 19. 0.25 is 12. Okay, next. What do we multiply to? What does 10 need to have as a power to get 1? This is like a trick question because the answer is 0. And anything with a exponent of 0 is equal to 1, no matter what that number is. Yeah. Another scatterplot question. Uh, Feet is our horizontal axis, so 35, 35, 20, 25, 25 again, and 15. 4, 2 and 1, 2, and then 12. Okay. This is a trick question, so it doesn't actually show us where the line intercepts on the y-axis, but we can deduce from the shape of the line and its position that it has to intersect below the x-axis, meaning that it's a negative y value. So we're looking at A or D, and then from here I'm gonna just say 2.5. This is a bit of a cop-out answer, but if it is 0.5, it would be definitely a flatter line than this, because um, maybe I'm wrong. Let's see. Okay, 0.5 times 0.5. 0.25 minus 0.5. No, yeah, okay. So it has to be this. Not for sure. 2.5 times 1.1 minus 0.5, 2.25. Which line fits the data graph below? None of the lines fit the data. So basically, you can't really do linear regression or linear estimation, linear equation estimation, if your data doesn't follow an evident linear trend. This is like some kind of like bow shape. Yeah. All of the intercepts are good. It starts at 40 and goes down to 20. So what this looks like is um here we can do one. Y at 40 is 20 equals m, and x is 40 plus 40. So all we got to do here is move stuff around. This becomes minus 20 divided by 40 equals m. So we have negative 0.5. This makes sense. It's asking for a percentage as a final answer, so what percent of adults smoked in 1997? Years since 1967. Okay, 1997 was 30 years since 1967. So 30 years over here, and it looks like roughly 25% of adults who smoke. I'm reading the thing over here. Was 25%. Yeah, let's go with that. Let's just see one more time. I don't know why I'm verifying this, but I will. Yeah, 25%. Okay, period. Pop. Yeah. 1, 6, 2, 3, 4, and 5. 1 goes to 95. 2 goes to 70. 3 goes to 90. 4 goes to 65. 5 goes to 70. 6 goes to 85. Ah, you gotta be fucking joking. Which one did I fuck up? Nah, I fucking moved this like to the side. Really? Wait, what? This one as well? Fuck. No. I'm gonna fix it in my spare time, but fuck, yeah. No. Okay, this is the unit 4 start. Okay, so apparently that was unit test 3. Swear. Unit 4 start. 1 hour. Okay, I'm gonna take a break and resume in the morning just because I'm a bit tired. Had a super eventful day, guys. Lots of dramas, lots of, dude. It doesn't center around me, but it's like just witnessing it, man, that shit tired me the fuck out. No swearing. Okay, be right back. Okay, good morning, everyone. Back from the sleeps. To be honest, I woke up at around, I'm gonna say like 8, maybe 9. Maybe you can tell by my voice, but yeah, I've been procrastinating for at least the past 2 hours. Did some laundry, had a meal, all that good stuff, but still gotta do 2 more hours of math. So we're gonna do that right now. Oh, oh, got meaning of percent.
Below. Before
This is super
9
easy. It's
tires
like,
where?
you know, you learned this in grade 1, so I'm just gonna go through all
A
of
whole
this.
percent.
Yep, finish.
And we're done.
Next exercise, we're gonna just we will just pop on over to the next thing.
So the goal
Again, super basic stuff.
here.
Let me just blast through it.
Use a number line to compare
Let's see
11.5
actually
and
if
11.7. So let's draw a number line here. I'm going to focus between 11 and 12 because that's where our
if
camera
I
is
let
sitting.
it play
11 and then something
throughout
else,
the
a number of
entire
tenths. So this right here
duration,
is 11.
does it
This
give
right
me a
here would
different
be
thing?
12.
Does it say
And then
I've
let me draw the
completed the
tenths. So
video?
this would be smack dab in between. So that would be 11 and 5 tenths, or that would be 11.5. Well, I've done the first
Let's
part.
see.
I've figured out where 11.5 is. It's smack dab
They
in
have
between
a
11 and 12. It's 11 and 5 tenths. But let me find everything else. Let me mark everything else on this number. So
typo
it's 1
over
tenth,
here.
2 tenths, 3
First
tenths,
time
4
I've
tenths,
seen
5
that.
tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and then 10 tenths right on the 12. It's not completely drawn to scale. I'm hand drawing it as good as I can. So where is 11.7 going to be? Well, this is 11.5, this is 11.6, this is 11.7. 11 and 7 tenths, 1 tenth, 2 tenths,
I'm
3
just
tenths, 4
letting
tenths,
it
5
play
tenths, 6
through.
tenths,
I
7
already
tenths.
know this
This is
stuff.
11.7. And the way we've drawn our lumber line, we are increasing as we go to the right. 11.7 is to the right of
Lumber.
11.5. It's clearly greater than
Number.
11.5. 11.7 is greater than 11.5.
Okay.
And really, seriously, you didn't have to draw a number line to figure that out. They're both 11 and something else. This is 11 and 5 tenths. This is 11
Just
and
want
7
to
tenths. So
see.
clearly this one is going to be greater. You both have 11, but this is 7 tenths as opposed to 5 tenths.
No, you don't really get anything. Oh, you do. I don't want to go through all of it though. Okay. 3/10 is. So this is like. This is 0.3. Oh, like that. What? Oh, what am I doing? Equal. Right is bigger. Left is bigger. What are these? No. Left. 7900s. Right. Right. Yep. Next. No, we'll just go straight here and start solving. These are all super basic things, so you know. Let me just timestamp that. Basic decimal and fraction stuff. At the end of the day, this stuff is like, you know, super basic, elementary level things. So
I have to compare
let's
these two
go
numbers.
skip to the end. Oh fuck, I don't think I get the. Oh, that's fine. Compare. Wait, what? Okay, this is. I guess we're talking about. No, we'll see. That one. That one. Tenths. Equal. Fuck. Oh well, good thing it's only 4 questions. And 19th tenths. This is actually more. This is more. Same. 2/10 is higher. Next. Order the following from least to greatest. Okay. This is probably the greatest. Not this is the greatest, and then that's the least. What? 6 tens. Oh, tens. My goodness. Okay. This is gonna be the greatest. Nah, this is the greatest. Nah, this is the greatest. What? 141 over 100. This is one from least to greatest. Fuck. I thought it was greatest to least. Least to greatest, okay. That's super small. 1300ths. This is the smallest. Less than 0.2, okay. This and this. Least to greatest, okay. 2 ones is the biggest, probably. This is 2.2, or 0.22. Which of the following are greater than 1.27? Hmm. Which of the following are greater than 1.27? Definitely that, and not that. This. Give me a sec, fellas. Just need to text my sister. Yep, let's more speedrunning. Let's get more speedrunning done. Time for a quiz. We're blasting through these sections so fast, it's not even worth creating new chapters, so. Okay. left. Least to greatest. This. Oh, didn't mean that. Yep. Shaded area as a fraction looks roughly half, so 0.5 and 50%. 2/10 is greater. 2.4 is greater. Nice. Next, lesson 3. Adding and subtracting 3 fractions.
So we want to figure out what 1/4 plus
Stuff
3
is
fifths
super
minus
simple,
going to
so
be 11 18ths.
we're just gonna go through all
So
of
we have
this.
blank plus 1/6. All right, now let's work through this together. Well, one thing 12s for our.
Yep. Let's do a quick review, quick example. How do you add and subtract and operate on fractions? Okay, so let's do some fraction anatomy. You have your numerator, we'll call it A, well, A, and your denominator B. And what a fraction is when you divide something by another number, and it's essentially just division, but written as a number or as an expression, a fraction. So A is the dividend and B is the divisor, which is the same as A divided by B, which is the same as saying how many times can you take B out of A. So what that might look like is if A is equal to 6 and B is equal to 2, how many times can you pull 2 away from 6 until you're left with nothing? And the answer will be 3. If the numbers aren't divisible by, if the divisor, if the dividend is not divisible by the divisor completely, then you end up with like a weird number, the decimal number, floating number, right? And so when it comes to fractions, all you want to do is make sure they have the same denominator. And how you do that is by multiplying. Do I even need to explain this? Nah, it's all good. I won't. Yeah, which fraction makes the addition true? No. Uh, hmm. 3/10. Okay. This is gonna be so. Okay. 2.5 and 6. Okay. 8.5 minus 3 is 5.5 over 10. Then multiply that by 2/2. 11/20. I might be wrong here, but let's see. 2/6. 2/6, yep. Over here, 3 and 2, 5, 11/6, 10/6. Is it 10/6? Half and a third. 3 and 2, 5/6, 5/3. Multiplying two fractions. And then
Or
it's
ask
just
for
multiplying
terms.
fractions. Pretty easy. 32. It becomes, for multiplication, you just multiply the numerator and the denominator. So it becomes 32/63, which is that right? 16, 32. Yeah, that's fine. 6 over 10, 3 over 5. 14 over 45. 15 over 35, which is 3 over 7. 7 over 10. 2 over 30, or 1 over 15. 21 over 20. Yep. And then dividing fractions.
So 30/5.
Divide. Think about it with other numbers, but hopefully that gives you a little bit of an
Yeah, dividing fractions. 3 over... Oh, wait, hold on. Then here we cross multiply, so we go 3 times 9, that's the numerator, and then 1 over 5, that's the new denominator. So it becomes 27 over 5, 21 over 24, 25 over 12, 64 over 35. Quiz. 24 over 15. 49 over 36. Am I recording, by the way? Yep. Which makes fraction? Oh, yep. So I'm gonna say we're gonna have to work with 12. Actually, let's just plus. This looks really bad. Okay. So it's gonna be 4 over 12 and 8 over 12 plus. Wait, what am I doing? Three over 4. No, it's 8 over 12. Wait, what? 3 over 4, 4, 4. Oh, 9. 9 over 12. 9 plus 8 is 17 over 12. Yep. And then 4 over 9. 12 over 12, which is just 1. Next. Okay. Introduction to probability. Oops. Probability.
what I want to do.
So what probability is... How can I explain this without jargon? Well, my intuitive explanation of what it is are the chances of something happening. Of course, we don't use the word chances, we use the word probability, which is like mathematically recognized term. And so if you think about flipping a coin, there are 3 probabilities. I mean, 3 possible events. You flip the coin, and then you either get the heads, a tails, or there's a very slight chance that it lands on its side. And if we kept this experiment in a vacuum, you would see that the probability is close to, like, half-half. So half of the time it's coins, heads, half of the times it's tails.
In this video is give you at least a basic overview of probability.
Give me a sec. Back, okay.
Probability, a word that you've probably heard a lot of, and you are probably a little bit familiar with it, but hopefully this will give you a little chance, not more. What is the probability? I'm going to flip a coin. I'm going to flip a coin.
See how
I
he
want to know what is
explains
the probability of
probability.
getting heads, and I could write that like this. The probability type is. Well, look, how many different
Yep,
equally
this
likely
is probability notation. This is how you represent probability. So it's P, uppercase P, parenthesis, your event, and you just read this as the probability of event H happening.
possibilities are there? Likely, equally likely possibilities. There's only two possibilities. We're assuming that the coin can't land on
And probability always adds up to 1.
its corner and just stand straight up. We're assuming that
If you add the probabilities of all possible
lands
events.
flat. So there's two possibilities here, two equally likely possibilities. One, that as a percentage, we know that 1/2 is the same thing as 50%. Of your physics or all the rest. Anytime if our coin be flipping real, the more times the one ask of those me equally I could roll. Probably get to argue this out right over here. Equally likely possibilities when I roll that die. And which of these possibilities meet my conditions? The condition of being even. Well, 2 is even, 4 is even, and 6 is even. So 3 of the possibilities meet my conditions, meet my constraints. So this is 1/2. If I roll a die, I have a 1/2 chance of getting an even number.
Okay, fair enough. Okay. Simple probability.
Find the probability of pulling.
Okay, so we're given a problem. Find the probability of pulling a yellow marble. So what it's asking is, out of all of the total possible events, what are what no, wait, let me rephrase. Okay. What is the probability of pulling a yellow marble from a bag with these different marbles? And the way you calculate that is by listing all of the number, pretty much summing the desired outcomes and then dividing them by the total number of outcomes. So what I mean by that is okay, so there are 3 yellow marbles and it's asking us what is the probability of pulling a yellow marble from the bag. So there are 3 yellow marbles to choose from, so you don't this is not important. You don't have to keep track of the different events, but there's yellow marble 1, 2, and 3. So you have 3 desired events, right? Okay, now how many events are there in total? So you have 3 yellow, 2 red, 2 green, and 1 blue, which means that there are 8 marbles in total. So again, you just go back, desired over total events, that's 3 over 8.
8 possibilities to satisfy yellow marble. Well, how many different? Well, there's 3 of them that are actually.
Okay, non-blue marble.
Let's do a
What is the probability of randomly selecting a non-blue marble from the bag? Now, we're probably we're probably not too far from learning about set theory in this prep course, but with the non-blue marbles, again, go back to the formula for probability: desired outcomes versus total outcomes, or desired event over total event. What is a desired event in this scenario? It's saying randomly selecting a non-blue marble. So this is saying that anything that is not a blue marble is a desired event. So we have 3 green and 9 red marbles. So that's 12 non-blue marbles. So you have 12 as the number of desired events. And then for the total number of events, we have 14. So 12 over 14. Whoa, what the fuck is going on? Oh, wait. Yep, 12 over 14. A point is selected at random. What is the probability that the point also lies in the smaller circle? Whoa.
that the point also ones that meet our constraint of being a multiple of 5. There are 5, 6. Do another one. The circumference of a circle is 36 pi. Let's draw this. Let's draw this circle. The circumference of a circle is 36
This one
pi. So,
seems kind of
the
crazy.
looks
It's a
like a
circle.
circle than that. So let's say the circle looks something like that. And the circumference, we have to be careful here. They're getting
A point is selected at random from inside the larger circle. What is the probability that the point also lies in the smaller circle?
yes, interesting. So circumference. The circumference is 36 pi. Then they tell us that contained in that circle is a smaller circle with area 16 pi. So inside the bigger circle, we have a smaller circle that has, this guy right over here has an area of 16 pi. A point is selected at random from inside the larger circle. So we're going to randomly select some point in this larger circle. What is
the probability that the point lies in the smaller circle? Okay. It says also lies, but that's irrelevant. Our desired event is that it is inside the freaking smaller circle, right? And our total events are it lies in the whole circle. And it's always going to fit in the whole circle because it says a point is selected at random from inside the larger circle. So all we do here is we take the formula, desired events over total events, and our desired events will be the area, no, the smaller circle, and our total events will be the bigger circle.
Probability
So
that the point also
16
lies
pi
in physics
divided
going to be
by
the percentage of the
36
larger circle.
pi,
Yet
which
our
is
radius is
1/2.
yellow, including what's kind of under this orange circle if you want to do it that way. This area is the smaller, and the smaller one is the ratio of the areas, the ratio of the smaller circle to the
Oh fuck no, I'm wrong. Jesus.
larger one,
Oh no. Okay, so he actually got the area.
and that is 480 once, I guess is the best way
Oh,
to say
I
it.
see. Oh, so it's pretty much the same thing, but he used area, not the circumference. Simple probability. What does P roll A to? Ah, P roll a 2. Okay. 1/6. What does P call a person not from his neighborhood? He has 25 total contacts. Any of those are from 5/25, 1/5. What is P chicken? 7/6 plus 7 plus 10, 7/23. What is P blue? 1/4, because there's 4 colors, and they're equally the same size. P select an apple. You have 4 apples, you have 5 bananas, 4 plus 5, 9, 4/9. What is P not shaded sector? Okay, these white ones are the not shaded sectors, so there are 6 of each, so 1/2. P not 3, so if it's not 3, then it can be 1, 2, 4, 5, and 6, so that's 5/6. Next.
What I hope to do with another question. What is the probability of rolling a number greater than or equal to 3? Well, once again, there are
Probability of 0 means, not happening, and a probability of 1 is it's definitely happening. It's the only event that
6
can
equally
take
likely
place.
possibilities, and how many of them involve rolling greater than or probability? But what's the range of
Huh,
they look
okay.
like larger numbers than 1, and you're probably thinking of seeing this at
Yeah, this
less
is fine. We'll keep going. Which of these events is more likely? The probability of his having a successful dinner date is 55%. The probability of his having a successful movie date is 0.45. Yeah, successful dinner date is higher. Put the following events in order from least to most likely. Okay. Least likely is Ali wins, then Marvin wins, and Hank wins. Which of these events is more likely? Uh, investing in stocks. From least to most likely, home run, 19 home runs, 40 plus, then 20 to 39. Which of these events is more likely? They're the same. Least to most, uh, leaves early, leaves in time, and then the last one is leaves late, 0.4. Which of these events is more likely? Ahmed, okay. Checkers, chess, wins the chess game. Okay, next. Experimental probability. Oop, I need to pee. Okay, back to the math. Experimental probability. Okay, so what is an experiment? An experiment is a set of trials. A trial is a single... Fuck, I don't know. Let me think. A trial is essentially like okay, you essentially try, that's what you're doing. You're trying to see what outcome you end up with when you run a trial. Oh my God. Okay. How would I explain what a trial is? I think that's literally what it is though. You're trying to see what event comes out of, I don't know.
There's a lot of times, there's a lot of situations.
It's like you flip a coin. Your experiment might involve 5 coin flips. Each coin flip is a trial. In a trial, you can get different kinds of outcomes or events occur.
In which we're studying something pretty straightforward, and we can find an exact theoretical probability. So what am I talking about? So let me write that down. Here your head, tail, and heads is one of those 2 equally likely possibilities. So you have a 1/2 probability. And once again, if in probabilities equal of these possibilities meet our constraints, so we have a 2/3, 4/6 is the same thing as 2/3 probability, even probability, because that's by default. Actually, I think you're in 20 games into the season, and you've been tabulating the number of points. You have a histogram of the number of games that scored between 0 and 9 points. You have 2 games that scored between 0 and 9 points. That went from 0 to 5. Game 17. You equal to 30 for game 17. Humans are in happily out of this to your experiment games. You kind of set up the path.
Okay, so I guess it's experimental probability is probability based on actual experiments done. What is a reasonable estimate of the probability that the next Tucker family vacation lasts less than 3 days? Okay, 1, 2, 3, 4, 5. What? Oh, 5 out of 9. 0.56. What is a reasonable estimate of the probability that the next type of stir fry ordered is shrimp? 5 over 9, 12, 18. 5 over 18. This one. What is a reasonable estimate of the probability that the next donation is not a pair of gloves? Okay. 23 gloves. 23 plus 5 plus 9 plus 3. No. 25 plus 23 plus 19 plus 3. And then 23 gloves over the total, 0.46. What? Is not a pair of gloves. Oh, fuck. Yeah. Again. Ready to practice. What is a reasonable estimate of the probability that the Ragin Cajuns score 30 or more points in the next football game? 30 or more points. So 3 to 5. 5 over. Oh, fuck. 2 plus 4 is 6 plus 5. Okay. It's definitely 5 over 16. 52 over 997. What is a reasonable estimate of the probability that the next tee shot ends up on the green? 4, 4, 4. Okay, so I'm going to do 4 divided by 4 plus 5 plus 7 plus 3 plus 5. 17%. Ah, 15 reaction movies. 15 over 108. What is a reasonable estimate of the probability that the next dad to join Dad's Club has fewer than 3 children? Okay. Fewer than 3. So this, and this. So 6 plus 4 plus 8. Fewer than 3 children. Okay, so 10 divided by 10 plus 10, 50%. 12 books, 20 magazines, 70 newspapers. Reasonable estimate of the probability that Stephen's next reading material is a magazine. 20 over 12 plus 20 plus 17. 41%, 0.41. Based on this data, what is a reasonable estimate of the probability the next customer to enter Jeremy's pet store exactly as 3 pets? Okay. Exactly 3 pets is 3 over 1 plus 1 plus 2 plus 3 plus 1 plus 2 plus 1 plus 1 plus 1. 1, 1, 2, 3, 1, 2, 1, 1, 1. 0. 2, 3. Nice, okay. Quiz. Doo -doo -doo. 15 over 108. Uh, Ella wins is quite high, Danilo wins quite low, and then Sophia wins is in the middle. Yep. Draw a blue marble. I can see 3 here, so 3 over 3, 6, 9, 12, 0.25. Which of these events is more likely? 0.32. Leaving her in a raft. What is P not purple? So there are 3 other colors, so 3 over 4. Okay, unit test. Let's add more chapters. Probably unit 4 test. Time is it? We actually haven't been running for too long, considering the fact that I did an hour yesterday and it's been like only 36 minutes now. But yeah, we've went through a lot of problems. 3 over 8, okay, 24 over 72, that is 1 over 3. 0.5 is higher. Least most likely, Phil, Rory, and then Ricky. What is a reasonable estimate of the probability that the next dad to join Dad's Club has fewer than 3 children? Okay, so it's 6 plus 4. It's 6 plus 4 divided by 10, 20, 50%. 20 over 54. Wait, is that right? 10 over 27. Okay. Let's make it 18. 24 over 18 minus 15 over 18 minus 4 over 18. Is that right? 2 times 3 is that? And 24. Okay. So 19 and the 5 over 18. Is that right? Yeah, I reckon that's right. 5 over 18. Oh, fuck. Now we have to go through the whole thing again. Fuck. Ah, okay. Whatever. 3, 38, 19 over 50. Oh my god. Decimal 0.38, 38%. Oh, 1 over 10, 4 over 10. Yeah, 4 over 10. Fuck. How is it not that? Ah. Okay, give me a second, guys. I need a little breather. And we're back. Ugh. Okay. 6. 8 times 7 is like a basic, 1-digit multiplication thing that I keep forgetting. I keep mixing up. I think it's 56. 9 over 10. 0.9, 90%. 20 over 27. The left one is bigger. The left one is bigger. Not sorry. Which of the following are greater than 0.85? This and that. Boom. Okay, 1/5 versus 15%. 1/5 is greater, that's 0.2. During dinner. Harry staining his shirt. Based on this data, what is a reasonable estimate of the probability that Stephen's next reading material is a magazine? 20 over 20 plus 17 plus 12. 0.41. Okay, solve this. 6 over 10 plus 7 over 10 plus 5 over 10. This is actually a minus. So 13 over 10 minus 5 over 10 equals 8 over 10, which is 4 over 5. What is P boy? And then we're choosing boys from a class of boys and girls. So 15 over 28. 15 over 28. Boom. Unit 5 start. Going pretty good, I'd say. Break. Okay. Predicting with probability. Yep.
So right over here, I have the type.
Predict the number of times a spinner will land on an elephant. Theoretical probability helps us get closer with our prediction, but we can't know for sure until we actually spin the spinner.
Type of a spinner that you might see in a child's game. You can see there's 7 equally likely possibilities. Let's see, there's 1, 2.
I think predictions, okay, and probability. Like if you're trying to make a prediction for certain outcome, all you do is take the probability. Let's see. Okay.
All right, so I'm assuming, like always.
Predict. What are we trying to predict? The number of times we get an elephant. So we have the number of trials and the theoretical probability of getting an elephant. It's 4 over 7. So what we do is we do 4 over 7 times the number of trials, which ends up being, I don't know, like a number.
Pause the video and
And what it means is that we expect to get 120 120 elephants out of 210 spins. Okay. Margot is going to spin the following spinner 210 times. The spinner is divided into equal sections. Okay, what is the best prediction for the number of times the spinner will not land on an elephant? Will not land on an elephant, okay. So we have 210 trials, and the expected value for the event we're trying to predict, or the probability of the event we're trying to predict, is not land on an elephant. There are 3 non-elephants, and we have 7 slots, so 3 over 7. So 90. Yep. Complete the following statement with the best prediction. The coin will land tails up. Close to 225 times, but probably not exactly. Yeah. Best prediction for the number of times Chen will listen to a classical song. Okay, so there's 4, 3, 2. Okay, so 4 out of 9. No, 4 out of 9. 4 out of 9 times 360, close to 160. Mikhailo will listen to how many country songs? Okay. 2 out of 6, 9, 2 out of 9 times 270, close to 60. Roll the number 4. 1 out of 6 times 2,400, 400. 3 purple marbles, 4 blue marbles. We'll draw blue marble. 3 out of 7 times 280, 120. The coin will land heads up. Probably not. Counting outcomes, flower pots. Okay.
So you're at a florist store and you're interested in buying some type of a potted flower. And you ask the florist, what type of flowers do you sell? And he says, well, we sell 4 types of flowers. We sell roses, tulips, sunflowers, and lilies. And
Counting outcomes. Okay. Flower
you
pots.
say, what type of pots could I put them in? He says, well, you could pick any.
Okay. So this is the counting rule in probability. So permutations, combinations, we'll be tackling those soon. But simply we can talk about how many outcomes are possible. So we have the example of flowers in flower pots. So let me actually update counting principle. 146, 47. We have a bunch of flowers: roses, tulips, sunflowers, lilies, and we have 3 different colors of pots. And so how many possible combinations are there? Right? And I just use the word combinations. The difference between a combination and a permutation is that combinations don't have anything to do with the order in which you select items or elements of a set. So there are either the same number or less combinations than permutations pretty much all the time. Okay. So there's like 4 times 3, there's 12. Okay, count outcomes using a tree diagram.
Let's cylinder engine, or
Yeah, this is super simple. You just list them all out. Counting principle. How many different outdoor expeditions are possible? Okay, so we do 4, 7 times 6 times 3. No. What am I doing? 4 dot 504. 2 times 4 is 8, times 4 is 32. 32 times 7, 224. 10 times 12 times 7 times 2 times 9. Typo. $960. 4, 2, 3, and 5. 10, 40, 120. 936. Wait. Yep, 36. 7 times 8 times 2 times 4. Oh my god, unit 5 is like so short. Probability model examples. Okay.
let's say that you love frozen yogurt. So every day after school, you decide to go to the frozen yogurt store at exactly 4 o'clock p.m.
Model the probability of a frozen yogurt line having 0, 1, or 2 people in it.
Now,
Okay,
because you like
simple.
frozen yogurt so much, you probably I the 1 person in line exactly. What would be your estimate of the probabilities of finding no people in line, 1 people in line, or 2 people?
Yep. So a probability distribution is exactly what it sounds like. It can be a table, and it is just a table where you have the different events that are possible events and their corresponding experimental or observed probability. Or it could also be a theoretical probability.
Outline 0, 4, relativity now frequency 18 divided by 50 0 0.2%. It's not going to be percent. And add up to 1.
So,
8 of your time. Whatever.
yep, okay. Develop probability distributions. Okay. Which graph represents an approximate probability distribution of walk-in customers on a random day? So 0 is going to be, uh, hmm. Okay, well, we have to do the frequencies, right? So there are how many customers? In the last 100 days. Okay, so let's see the total first. 3 plus 7 plus 13 plus 28 and 10. Okay, so there are 100 exact. So pretty much it's just this over the number 100. So 0 should be 0.3. No, okay, so that's wrong immediately. 0.03 actually. 3 should be just above. This seems right. Yeah, I'm gonna go with that. Casey recruited 40 people. Okay, 11, 4, that's 15. Then plus 8 is 23, and 17. So this is 17. And 11 out of 40. 0.275. Based on these results, which graph represents an approximate probability distribution of the difference on a random row? Hmm. Okay. 1,000 rolls, right? 100 is 10%. So all of these are pretty much like, just move the decimal point one space to the left. So 0 should be 15.8% or 1.58. What's this one? Manuel rolled the die 200 times. Okay, let's see. Plus 24, plus 30, plus 36. That's 36. What? 36 plus 62. Okay, 220 and 10. Fuck. I hate these fucking, like, god damn it. Try again. No. Okay, past 400. 160 out of 400 is 40%. This is the one. 60 dogs were used. Okay, so 30, 33, 45, 15, 0.55, 0.75, 0.9, 0.1. Wait a minute, 0.05? Yep. Okay, let's see the differences. There's 0. 290 is 0.54. Has to be that one. No. Where's this calculator? 290 divided by 500. 500 or 400? 0.58. It's this one. 36, 14, 14 over 50. Can also just do 0 0.12, 6, 0 0.44. Yeah, 0 0.18. Are you joking? Fuck. Am I doing something wrong? Fuck. 6 plus 14 plus 22 plus 8. Okay, what the fuck? 12, 0 0.18, 0 0.44 plus 0. Fuck, are you kidding me? Again. Try again. 2 should be just below 0 0.5, so it's this. Okay, what else is different? Okay, 4 should be slightly below 0 0.1, just slightly, so I'll go with that. 88 plus 164 plus 86 plus 56 plus 26 divided by 500. Okay, 110, 0 0.78. Wait, what am I doing? 110 over 500. Okay, let's see the differences. The difference is on the number 3. Yeah. 30 out of 200 is 15%, so it should be 0.15. This one. Okay, let's not fuck this up again. Okay. 18 plus 6 plus 2, 26. 18 minus 26, 54. 54 over 80 is 0.675. Yeah, that's correct. Okay, 18 over 80, 0.225. Okay, finally. Nice, another level up. Almost level 10, guys. Unit 5 test. Time check. 57. 57. Okay. Let's go. Just answer this, goddammit. 18 plus 2 plus 2 plus 6. 26 over 80. What am I doing? Huh? Not 18 minus 26. 54. 18 over 80. 0.225. How many different players? Okay, this is a counting the number off, counting principal question. 4 times 2 times 7 times 8. Which statement best predicts how many TVs will not be showing a sports channel? So everything but TVs is the desired outcomes, and then there are 110 TVs. Okay. Oh wait, okay. Yep. And 11 channels. So we're gonna do, okay, there are 7 sports channels, and we're trying not sport channels. Okay, so 4 over 11 times 110 should give us 40, but not exactly. How many different sweatshirt designs are possible? Again, counting principle question. We just multiply all the possible events. What is the best prediction for the number of questions that Amit will answer correctly? Okay. Only one is correct out of 4 options, and there are 20 questions. So 1 out of 4 times times 20. 5, but not exactly 5. How many walk-in customers were there in each of the last 100 days? Okay. Let's just double check how many frequency, what the frequency adds up to. It might not be 100. 39 plus 10. Okay, it is 100. Let's see where they are different. Okay, so the number of walk-ins 4 is different in each visual, so let's just calculate that. So 39 out of 100, 0.39. Yep. So just below 0.4. It's this one. Which statement best predicts how many football players will get a popsicle? Okay. 50 football players, 3 cooler of popsicles, 3 coolers of ice cream. This player's going to randomly select a cooler from which to get this. Okay. So we want the popsicles, so we're going to do 3 over 3 plus 2 is 5 times 50, 30. 30, but not exactly 30. How many different pizza combinations are there? Okay, so let's count them for each. There are 4 crusts, 4 sauces, 3 cheeses, and 4 meats. 192. Let me just double check I counted right. Yep. 60 dogs use toys. So we're just gonna do 0.25 times 60. 15 over here. And the probability of 3 over 60 is 0.05. What was I doing a while ago? I was answering it really weird. I was like doing the whole freaking row. What is the best prediction for the number of times the spinner will land on the elephant if we spin it 200 times? So there's 1 out of 5 sectors which have an elephant. So 1 over 5 times 200, 40, but not exactly 40. And we're done. Course challenge. Oh shit. Oh wait, this is the last episode in... Well, we're gonna keep going, of course, but this is just a get ready course. Super simple. Huh. Didn't even really think about it. Okay, I'm gonna... Now we're gonna finish this off here. Yeah. Resume course challenge. Resume. Okay. Give me a second, guys. Let me just like freshen up, you know, get the freaking vocal cords working. Yeah. Wonder if we'd even be able to do it. Fuck. I mean, don't see why not. Okay. And back. Okay. Ooh, okay. So, back here, you know, before I start the unit test, I just want to talk about the message at the start of the video. Victorious warriors win first and then go to war. Like, why do I keep saying like? Okay, let me repeat that. Victorious warriors win first and then go to war. What I mean by this, and what the author of the book that has this quote means by this, is that you have to prepare. If you prepare for an exam or a quiz leading up to the quiz, you know, subconsciously on the side, just casually, you'll probably be more prepared than the people who go, you know, 8 weeks prior to the exam, just entire 8 weeks of just fucking around and not really focusing on anything, and they just procrastinate in the final stretch, and that's not good because, I don't know, that leaks into different parts of your life. And so, yeah, if you're a student, if you're studying, make it a habit to learn as you go. You know, it's like being in the kitchen, clean as you go. Same with your house, clean as you go. Stay organized, stay on top of all of your studies and whatnot. Okay, so let's do this final stretch. and it shouldn't be of any difficulty because, you know, I'm a statistics guy and this course is really short. So, what is a reasonable estimate of the probability that the next customer to enter Jeremy's pet store has exactly 3 pets? And so 3 pets, we have 3 over here. Now we just need to look at how many there are in total. So 3 over how many total events? 1, 2, 4, 7, 8, 10, and then 13. So 3 over 13. It's this one. Find the mean of the data in the plot below. So we have 4, 4, and 7. So that's 8 plus 7, 15. Divided by 3 is 5. Let's see. Okay, so which line fits the data graph below? There's no clear linear trend, so a straight line won't fit. Which fraction makes the addition equation true? Okay, so let's make these terms similar first, similar denominators. So we would just multiply this by 8 over 8, which gives us 24 over 16. Then we transpose this, and we get 24 over 16 minus 1 over 16, which gives us 23 over 16. Multiply. 7 times 5, 35. 35 over 48. Solve for z. And this is what kind of problem is this? We're trying to factor out the z. Oh, yes, okay, so we're gonna move everything to one side. Right, okay, so I see, okay. So we're gonna end up with simplifying the left-hand side, we get AT plus AZ. Then we transpose the 45z over as well, so we get minus 45z. And then we're left with 67 on the other side. From here, we move AT to the other side, so it becomes 67 minus AZ. And then from here, AT. From here, we'll be left with this, AZ minus 45z. So we can factor out the z, and it just becomes A minus 45. Then we factor this out, so we are left with z. Z equals 67 minus AT over A minus 45. 67 minus AT over A minus 45. Express the shaded area as fraction decimal percent. This is a 10 by 10 grid, so each cube is equal to 1%. So 3, 6, 62%. 62 over 100, or 31 over 50. 0.62. 62%. Pepe is going to spin the following spinner 800 times. The spinner is divided into equal sections. This is a problem of I was going to say expected value, but no, we're trying to predict. Yeah, prediction problem. So complete the following statement with the best prediction. The spinner will land in the shaded region, the blue region. How many times? Okay, so we have how many sectors here? How many regions? So 3, 5, and 4 of them are blue or shaded. So 4 over 5 times 800 is 640. So close to 640, but probably not 640. Log A512, this is the same as saying, what do we multiply to 5, what exponent 8 raised to what number is equal to 512? And so we can just pop that into the search engine, times 8 times 8. Okay, so 1, 2, 3. 8 to the third power. Which of the following options have the same value as 10% of 33? So it would be 10% of times 33, 10% of 33, 10% of 33. Then the other ones are either too big or too small. How many mLs of alcohol are in the solution? Okay. 70% times 500, 0.35. Oh my god, I was about to get the dumbest mistake ever. 350. Left hand side is bigger because 16 over 10 is greater than 1, and on the right hand side we have a decimal that is smaller than 1. Find the median number of strokes. Okay, so first we need to organize the data. It's already organized for us, so we just have to find the middle. So we have an even number of data points. There are 6 people, so we get the 2 middle data points. Actually, no, it's not fully organized. This should be like this: 33, 39. So 25, 26, 31, 33, 39, 57. Almost got that wrong. Okay. We take these 2 data points and then we add them, then we find their mean basically. 31 plus 33 is 64, divided by 2 is 32. How many different shoe combinations can Arturo create? Okay, combination problem. How many possible outcomes are there? 8 times 5, 2, 5, 60. Based on these results, which graph represents an approximate probability distribution? Okay, probability distribution problem. Let's see where they're different. Okay, so if we're looking at 0 in the probability distributions, they have different values. So let's just see what the distribution should actually be at 0, or probability should be at 0. So it's 290 out of 500, which is 0.58. So it should be greater than 0.5 and just under 0.6. The other ones are too low, so we go with B. How many books did Marian and Wendy read in total? Okay, so we're adding this and this. Marian and Wendy. So Marian read 4 and Wendy read 9, so that's a total of 13. Which display can be used to find how many days had a high temperature above 15 degrees Celsius? I would go with the dot plot because it shows exactly the number, whereas the box plot only shows quartiles, which doesn't actually tell you how many. How many days exactly were above 15? Okay. Which display makes it easier to see that the first quartile is 9 degrees? It would be the box plot because again, the box plot is used for quartiles and minimums and maximums. Dot plot box plot. Solve for n. Okay. Again, this is a we have to factor out the n. Do we? Let's convert it to 0.5n so it's easier to for me to like work with, but it doesn't really change anything to be honest. Yeah. Let's transpose this over here so we get 2.5n. Transpose this over there so it becomes 16 minus 2. Feels kind of janky. Hold on. Okay. Negative 0.5n equals, and we transpose it 2 minus 2 to both sides. We get plus 14 instead of 16. 3n. Transpose this over to the other side. We get 2.5n equals 14. Then we just do n equals 14 over 2.5. Or 28 over 5, I guess. Oh man. Fuck. How is that not right? Ah, man, what am I doing? Wait, what? Low key want to restart, but I'm so fucking lazy. Okay. Okay, whatever. We're gonna end up with 6 over 2, 5 over 2, and equals 14. Then transpose. Divide both sides by 5 over 2. So it becomes... I'm quite bad at transposing fractions. N equals 28 over 5. Wait, what? Why is it not right? Dude, are you fucking serious? It's supposed to be minus 3n. Dumb. Okay, doesn't matter. Minus 14 equals 7 over 2 n, and then we do the same thing, minus 28 divided by 7 equals negative 4. Right hand side is greater. What is p salamander? 5, 3, 12, 5 over 20, 1 over 4. Which of these linear equations best describes a given model? Okay. So, okay, we can just go here. At x equals 10, we are at over here. So 1, 2, 3, 8. So 8, okay. 10 times what plus 28 will give us 8. Okay, minus 2x, that makes sense. Is that right? Minus 2 times 10 is minus 20 plus 8. 28 is 8. Yep. Minus 2 times 5.5 plus 28, 17. Find the mean absolute deviation. Mean absolute deviation. I'm trying to remember. Okay. 26 plus 31 plus 39 plus 32. You need to look at the formula. Mean absolute deviation formula. Okay, so it says x bar, x bar, x bar over n. Okay, so what we want to do instead is, okay, so there's 4 scores, and the mean is 32. 32 x1 minus x. Okay, so 26 minus 32, and then you get the absolute value. Then 31 minus 32 plus 39 minus 32 plus, and then 32 minus 32 is 0. So we end up with 6, 1, and 7. 6 plus 1 plus 7 is 14. 14 over 4, 3.5. Put the following events in order from least to most likely. Okay, so 10% is 1 over 10, so it's lower than this and it's lower than that. So Colorado Bronze wins. Then I Am Pat wins and Good Leg Alliance wins. Least. Yep. Create a frequency table. Okay. There's 1 0, 1 1, 3 2s, 1 3, and 1 4. Yep. Values from least to greatest. Okay, this is the least. This is 30%. 13 hundredths is 0.13. So like this. Frequency table. Using this data, create a dot plot where each dot represents a creature. Okay, number of legs is 0. There's 1, 2, and then 1, 1, and then 3 2s, and 2 3s. Which dataset could be represented by the box below? Okay, let's see. So they have the same maximums, but the minimum should be 4. Okay, let's count how many commas there are. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 3, 6, 9, 12, 3, 6, 9, 12. Okay, 3, 6, 9, 12. Okay, so these all have 12 numbers. So we know they're even, so we're gonna have two middle numbers, 6 and 7. Our median in the box plot is 9, as indicated by this line in the middle. So 3, 6, 7, right? So it can't be this because it'd be 8.5. 3, 6, 7. Can't be this because it'd be 10. 3, 6, 7. So 8 and 10 are the middle numbers. 8 plus 10 is 18, divided by 2 is 9, so that's our answer. Create a bar graph to show how many bee stings he has in each leg and arm. Okay. Right arm, 10. Right leg, 2. Left arm, 8. Left leg, 4. Plot the data in a scatter plot. Okay. Let's see, gold. Okay. 16 gold and 9 silver is, so just over here. And then 5 gold, 2 silvers over here. 4 gold, 2 silvers over here. 2 gold, 1 silver over here. 1 gold, 6 silver over here. 16 and 9. Yeah. Are you joking? Fuck. I hate these kinds of questions, dude. 1, 6. 2, 1. 4, 2. I did 7, 2. Fuck. 35 over 6. Two of my stuff went down. Constructing scatter plots went down. That's not good. Okay. Done. Okay, let's just fix this one last thing before, God damn it. I'm not very good with tests. 29 and 6. Right foot. Okay. We're just gonna do, okay, 29. 12, 24, 18 and 1. Okay, 1 and 16. And then 12 and 26. And then 18 and 7. 18 and 7. 24 and 1, and 29 and 6. Plot the data in a scatter plot. 6, 7.5, 0.5, 3, 4, 9.5. Then we'll do again. 0.5 is 7. 3 is 7. 4 is 5. 6 is 6. 7.5 is 7. And then 9.5 is 6. Okay, predicted 11, 13, 12, 17, 15, and then 17 again. Okay. Let's do 17 and 27. 17 and 16. 15, 15, 15 and 14. 13 and 15. 12 and 12. 11 and 14. Okay, period 1, 6, 2, 3, 4, and 7. 1 is 60. 2 is 55. 3 is 60. 4 is 80. 6 is 90. 7 is 95. Yeah. So that was pretty good. We got 93%. We got 2 mistakes. Pretty dumb ones, albeit. But yeah. Let's close this video off. Wrap up to 27, 50. So yeah, that was episode 3. Is it episode 3 or episode? Why do I keep my minimal pairs with S and Z are so bad. Episode 3 of, statistics. We finished the I didn't expect to blast through the units in this course so fast, but we'll move on to some college, university level statistics. We didn't really dabble in much stuff. I guess this was just like an introductory high school course, super easy stuff. Especially because I have a background in statistics and data science. So I'm not a complete blank slate like I was when I did calculus. Um, Not gonna lie, I think I found calc funner. It felt like I was like casting spells and stuff whenever I'd pull stuff out of my memory. But yeah, this isn't the end of this season. I'm gonna go ahead and start the next course in the next video, however. But yeah, if you are for some reason watching the end of the video and you skipped all the way, like feel free to leave a comment below, leave a subscribe. My subscriber count, our subscriber count, it's not just me. Our subscriber count has been going up. When I say it's not just me, I mean you guys as well, because you guys are part of my channel now. Even if no one really like comments and stuff regularly, we're up to 66. Can't really believe it's only been like 3 months, and yet somehow the channel is growing. It doesn't really make sense to me, like why are people subscribing to my channel if nobody comments, my watch times aren't that long, I mean, sometimes people comment, people say thank you, people say they get inspired. So I'm glad people feel that way about my content. But yeah, I just want to say I appreciate all of you. I appreciate the comments. And I will see you in the next video. Bye bye.